Hi everybody, my name's Anthony, and I'm the product designer within the System Dynamics group at MSC, and that's the group responsible for producing Atoms and EZ5 products. So welcome to the webinar. As the introduction stated, this is a first in a webinar series around trying to educate folks on what is all in their MSC One investment, try to maximize the value of your MSC One investment. So that's what this series is about, help you realize what software products are out there and investigate what kinds of problems they might be able to solve and benefits they may have for you. Maybe think about ways of connecting some of these products for co-simulations, supporting, maybe a massive use of one product with occasional use of others, and want to keep up to date on these other tools and what can be going on. So these webinars will be held every 2 weeks, and they'll be recorded and posted in the MSC Communities area online for consumption after the fact as well. Just to be sure we're all on the same page, what is MSC One? So MSC One is MSC's newest, relatively new, I guess a year or two old now, licensing model that covers all current and future products. And so this main benefit here of MSC One is that it eliminates a lot of the limitations we've had in previous token systems, whereby certain products were available, or certain features even within some product families were not available or came with an extra uplift or something like that. So that's the main benefit of MSC One, is to really get all current and future products of MSC. And the subscription, it's a lease-based, subscription-based system, and can be expanded and contracted, therefore, based on your current needs and project loads. As I mentioned on the first slide, it does provide access to some more connected physics and different disciplines, maybe co-simulation examples that are shown here as well, and you get to build, you have the ability to leverage the full ecosystem of products around MSC. So, for example, Nastran, Atoms, Digimat, Actran, SC Tetra, all of the MSC products, as well as new modules that are coming out. When they come out, they become available on the MSC One system. And this slide here is just a current display of the large product families, the high-level product families that are covered by MSC One. That purple A here in the middle is the one we're going to be talking about today, for the most part, and that is Atoms. So, like I said, I work in the Atoms product development area as product designer. Makes me the requirements guy, and I'll be taking us through what we can do with a part of Atoms called Atoms Explore. So I'll describe the high level what Atoms Explore is, what the benefits are, illustrate how the workflow works in diagram form, and then we'll get into more description of the interface itself and a demonstration. So what's Atoms Explore? Atoms Explore is a spreadsheet interface for Atoms View and Atoms Car. So the purpose of this is to enable non-Atoms users the ability to exercise an Atoms model from a familiar spreadsheet environment like Excel. So the Atoms users are the ones that control the content of the spreadsheet, what types of parameters in the model we're going to allow people to change, what types of outputs we're going to allow people to see, and then they can send those to other folks, non-Atoms users, don't know anything about the Atoms interface, for example, and from which then this Excel spreadsheet is where those users, non-Atoms users, could change, perturb model values, run simulations, and look at results all right within the spreadsheet environment. And this has been around since the Atoms 2016.0 release, and continues on in later versions. So what are the benefits? For the non-Atoms user, the benefit is I get the ability to perform what-if studies without having to wait for my CE analyst colleagues who have day jobs and are probably busy doing other things, and I just want to see what happens if I stiffen a damper, move a key design point, a hard point in the mechanism design, and just see what happens to some of my key output metrics. So I can do that without having to pester my CE analyst, friends in my company. I can do that without having to have knowledge of how to use Atoms, how to build models in Atoms, how to launch the software, how to run analyses. I can do all that without having to do much more than click a few buttons through Excel. which is, of course, a familiar interface for most engineers and engineering management folks. Also, it allows me to submit analyses and look at results from any platform, really, that has a compatible spreadsheet editor. I will say the word Excel a dozen times today yet, more than probably the dozen I've already said it. But the point is, it's an XLSX file, so really any XLSX file editor, particularly for folks on Linux platforms, there are a few that support that. Anything that supports the XLSX file ought to work and be also useful as be usable for the front end and using those spreadsheets. And the other point on here, the last bullet makes, is that the things are easily distributable because of centralized storage of the model. So the model, the Adams model, the Adams solution, all of that is centralized on an Adams server, and we'll get to that in a diagram in a few minutes here. But what that means is we're not worried about passing around model files left and right, and well, did you include the MNF file for the flex body when you sent that model over to somebody else? You don't have to worry about any of that sort of thing, because all you're really sending out is the spreadsheet, which then simply goes back and talks to a server. So we'll get that in the diagram. I'll maybe make that point a little bit more clear later. Now, there are also benefits for Adams users. I was just describing what a lot of the benefits are for the folks that get to consume these spreadsheets, perturb models, run what-if studies on their own without having Adams experience. But even Adams users like this functionality, use this capability themselves. Allows them to reduce, first of all, allows them to reduce those design simulation iterations we just described earlier on the previous slide. There's, of course, the flip side of that coin, right? They have Adams users have their regular day jobs out there trying to build models to extend the number of tests they can cover virtually, rather than just running a bunch of one-off what-if studies on existing virtual test patterns. So can unload some workload from those folks. It's also more selfishly, also for the Adams user, it's a convenient way to modify commonly tuned parameters in a model. Sure, you've got ways to perturb all these things with the Adams GUI, but again, it's Excel. It's really easy. It's all right there in a table. Maybe a nice way to do it, particularly if you're going to group. You want to keep together a coherent group of the analysis, the event I'm running, the analysis settings, solver settings I'm using, the specific model I'm using, and have that all in one document that says this represents the life of the problem I'm trying to solve, not here's a file for a model, here's a file for output, things like that. It kind of helps keep things together, a nice organizational tool in that regard. You can also package a number of analyses in one document, so you can submit standards for the suite of analyses. And it's configurable and customizable. So for those that are deep into the macro language or the SimAcademy view command language, it's got a lot of capability to execute your own scripts and things prior to and after the analysis. And there's even access to sort of the low-level read and write functions to and fro the Excel sheet, so you can really do a lot in the ways of customizing and extending the Excel sheet itself and what you're doing there. Okay, let's move on to the workflow. We've got a couple of different user personas here. We've got the Adams analyst, as we described. This is your expert on the left-hand side here, knows how to model things in Adams and knows how to run Adams. Maybe be their full-time job. And you've got a set of typically a larger number of engineers who work in the same company, but don't use Adams, and so those are the folks that want to consume things in the Excel workbook format that we described. And then that Excel workbook talks to an Adams server, which is maybe a dedicated server set up by IT that's accessible on the network from where these engineers sit, or it could even be the analyst's box or the machine in the analyst's neighbor's cube or something that's a high-powered machine, the CA group or something like that. The analyst, that the analysts themselves use and set up and manage for the engineers. And then lastly, that last arrow that popped in there, there is a feedback loop from the Excel sheet to go back and update the model for the analyst. And I'll illustrate that a little bit in some of the demonstration materials we've got later on. In terms of specific listing the features that are supported in Adams View, the kinds of things that we allow in terms of modeling entities, the kinds of things that we allow people to change, that the Adams analyst can allow people to change from Excel. Those things are listed here. The usual things you would expect, especially design variables, right? These are the parameters that we can set the model, using the model for parameterization. Point objects. Think of those as hard points in your models, mass properties of parts, motion functions even. If they expect folks who are consuming this can understand the Adams function syntaxes that are used, and even data splines that may represent stiffness versus stiffness curves or damping curves or a number of other things. All the Adams analysis types are supported, so you can run view command scripts, ACF command scripts to do any of the various types of analyses, static, dynamic, etc. Output things that we allow to be exposed within Excel are evaluated design objectives. So these are sort of name value pair scalars, but then also plots. So anything that you can dial up in the plot config file and create a plot template for, those things essentially are used to instruct Excel to, hey, grab this data, put this data in the sheet and plot it, and using Excel plotting within Excel. So let's take a little bit deeper look at how this really looks and feels within the Adams View environment. Up on the Design Exploration tab, there's an Explore container, and there's an output or an export arrow there up to the right on the top, and that one brings up this dialog that you see here. So say we've got this is a basic latch model, and trying to find out more or less with a constant given input, maybe some sort of a maximum allowable input that we want the user to have to exert to operate this clamp. What kind of clamping force do we get? And so the key things in this sort of mechanism would be these hard points that are located around at key junctures in the linkage where the linkages connect, so lengths of these links and where they connect up. And so you can imagine stiffness in the spring, perhaps is another, in the spring damper, these characteristics, another pretty significant design parameter of this system. So you'd want to make sure those things are parameterized in design variables, or there's hard points that are leveraged for those things. Maybe even the mass properties of these parts are important. So we can include all those things and select them from the model. So it's an interface that really lets you pick and choose what subset of the model you want to expose to the engineer users. Then our Adams analyst, she may come in here and then set up all of the analysis information. So this is sort of basics about where's the server that I think my colleagues, the engineering colleagues, they're going to be able to reach, what server they're going to be able to reach. The engineers consuming this aren't going to know what Adams launch commands are. So this thing helps set all that up. A few basics about the analysis. It also is where we set up what output she wants the engineers to be able to see. She may want them to be able to see two design objectives: the clamping force of this thing and the over center angles. Kind of basically shows do we clamp it all the way did it clamp all the way down, or did it not, with the 80 Newton force we're going to apply. And then you can also come in here and pick what's the simulation script, and what's the analysis name that we're going to call this thing to run. The simulation script, of course, really defines the event. It says what's the event that we're going to run. Well, the event is we're going to ramp on this pulling, this force here representing someone pulling down on the clamp. And then lastly, she specifies, maybe most importantly, a plot configuration file. It specifies, well, what are the plots that I want to allow the folks to look at. Again, key output metrics that we may want to look at. Once she's exported that workbook, she can just email it off then to her engineering colleagues, and they may look at this and then open this up and say, okay, I can see I've got a model tab here where I've got some just basics of the name, rank, serial number of the analysis or of the model. Also have the solver settings in here. Engineering probably doesn't know what to do with those things. He doesn't speak Adams solver setting, but they're in there in case he gets into trouble with the model. Maybe you can call up his colleague and see and ask her, I have a problem with this, and she may say, well, okay, try try loosening air, or try changing T-limit or something like that. There's a tab then. Now there's tabs for all the other items, basically the model parameters that we've chosen to expose, and the model characteristics we've chosen to expose, the points themselves, X, Y, Z values for those hard points, those design points, with the linkages in there, design variables for a number of things, most notably the spring damper, mass properties for the parts, the design objectives we talked about are listed in here. And then there's an analyses tab in here that explains, okay, here's the analysis where it's going to be run, etc. And there's this Adams Explorer Server tab. Basically, Adams Explorer is an add-in to Excel. It needs to be added into Excel one time, and then it's there, and you've got this tab, and you can use that to manage the jobs. Click Submit Job and go through. The job basically goes off to the server and runs, and then it comes back with basically a hyperlink to download the output version of the workbook. It sent the workbook off to the server did its thing. Now I've got this workbook that's come back to me with some values for my design objectives. I see here, clamping force is only 400 newtons. I was hoping that'd be around 800, I think is what I'm guessing I'm going to need. That doesn't look good. Over center angle, the end of the simulation doesn't look like it's where it needs to be. That's supposed to be kind of near 0. Let me look at some plots. Sure enough, here's a plot of the over center angle versus time. I can see I'm clamping, and then it kind of kicks back on me, and my force that I'm applying isn't enough to finish the clamping job. Same goes to these guys. See, the clamping force is moving forward, but then it kicks back and starts to reduce. Okay, too bad, so I need to change the design from the baseline that the analyst had. So, as an engineer, I look at the diagram, I realize I could maybe move a couple design points, hard points a little bit, and maybe get a better result. So I go ahead and do that, rerun the model, and I can come back again and see now I'm getting 800 newtons, over 800 newtons, and right around 0, pretty close to 0 for my over center angle. I look at that plot, I can see, yeah, I'm now completing the clamping job, so that looks good. And I'm getting a nice smooth clamping force, doing what it's supposed to be doing, not kicking back at all. So I'm happy. So happy that I want the CAE analyst to be able to consume what I just did and make that their new baseline. So maybe I kind of get it going based on these few key metrics, and then say, okay, Ms. CAE analyst, please go ahead and run your full battery of detailed stuff based on what I just did. So she can take the Excel workbook that I just produced with my favorite settings in it for those, in this case, those hard points, and she can import that back into her Adams model and say, okay, I like everything you did in there. I want design variables. I made up checkpoints, whatever. Or she can take a subset of it too to say, well, I only did this changes from the design variables. It was really just the points you wanted me to add. Whatever it is, can basically update the model with those values. And then CAE analysts can be in sync with sort of the design engineer's favorite set of settings after however long they spent iterating, trying to kind of get it right to where they want it to be. So that was a trip through things in Adams View. Let's take a look at Adams Car. So Adams Car, as many of you may or may not know, is an extension of the core Adams product, the core Adams View product. So it has a lot of customizations just for folks who make things with 4 wheels and a steering wheel and an engine, brakes, that kind of stuff, called cars. Within Adams Car, that means then the types of things that are supported for export to an Adams Explorer workbook, Excel workbook, are an extension of the things that are there for view. So you can see a list of a lot of these things here. So a lot of similar things, hard points, mass properties, parameter variables, that's what car calls a design variable. UDEs, those are these sort of higher order objects that are specific to things in car, a bushing, a rebound stop, these kinds of steering assist, these kinds of things. There's also, again, splines, as we mentioned before. Car also stores a lot of properties of things out of the model in these things called property files. So you could just grab the different tires properties or the different bushing properties that way as well. So those things are all exposable for the Adams Car analyst to give to his engineering friends. Analysis types, again, cover runs the gamut of the typical Adams car analyses. For running a full vehicle, you can use the file-driven events to run full vehicle analyses, a couple of different suspension analyses, the general, some actuation analysis also supported here. And in terms of output, similarly, design objectives, plots from a plot configuration file. And I did mention it with the view demonstration there, but all the normal Adams analysis output files are available too. You can go onto the server and grab those. If you really want to bring those down, maybe send them back to your CAE Adams analyst colleagues and have them do something with them or look through them in more detail if you've got questions about things. So we're going to take a look at an example of doing this in Adams car with a vehicle driving over a pothole. So that's the event that we're interested in, and as the Adams analyst, I'm going to be in Adams car, and I want to essentially allow the engineers to improve the vehicle's performance over that pothole event. So same as I was showing in Adams view, I open an export dialog where I can provide some names and then most importantly select the kinds of things that I want the engineers to be able to perturb in the model, the things I want them to be able to vary. Rear suspension and front suspension hard points, so those key characteristics of the geometry of the suspension. Mass properties on the body, maybe I want to see what happens when the body's heavier or lighter. In this case here, parameter variables that allow me to scale springs and dampers in the front and rear suspensions. And here also is, this is where we're actually, those parameter variables, where other parameter variables related to the front and rear suspensions. Here, when I pick these UDE elements, I'll get the parameters on the UDEs for the dampers and springs. So these allow me to scale springs and dampers curves, which may or may not be linear, right? And but I can scale them by a factor, a single factor, if I just want to stiffen them up or loosen them up a little bit. But since they can be nonlinear, I may also want to export to the engineer the spline, and then let the engineer maybe let the engineering folks look at changing the shape of those curves as well. So those can just come in as XY data or XYZ data, depending in Adams Explore Excel sheet, and they can edit the shape of those curves then directly and visualize the shapes of those curves. In case they want to actually not just sort of, stiffen them up, by a scaling factor, but really change the characteristic shape of the curves. As I mentioned before, we can put property files, and here the analyst is exposing the tire property files. It may be important to put a better tire model on this to run over a pothole, but hopefully they would have the best tire model, the appropriate tire model for that, and really leave it to the end user just to evaluate the difference between tire models, instances, let's say, different maybe tire radius or different tires that have slightly different stiffness and such. Here on the analysis tab, pretty much the same as what we saw in Adams view. Set up the coordinates of where the machine is going to be, the machine is going to host the model modification and model execution solving, as well as set up the analysis, define the analysis. Now, it's a little bit different defining what the analysis is in car than in Adams view over there. Here we've got a road file and a driver file, and we'll drive this way over that road, in this case 50 kilometers per hour straight ahead over that potholed road. And then again, provide a plot configuration file that will auto-generate the plots for the end users, the engineers consuming this. Okay, so our CE analyst here has exported now the workbook, and then the CE analyst could also be the one that is starting the job server and web server, and his machine is being used for this, as engineering colleagues may be doing that, so he's setting that up now, but that could be a dedicated machine somewhere where an IT person's doing that. We can see that that workbook was just exported to the working directory, and now maybe he sent this off to his engineering colleagues who are going to look at this and again look at sort of these basic data about the model, and now can look at all the different things that are exposed. Those green colored cells in there, I mean, hey, these are things you can change, right? You can change those hardpoint values. You can change these parameter values about the suspension setup. You can change these mass properties of the body parts. scaling factors here that we can change. And then here are that spline data for the dampers and the ride springs in the suspensions that, again, you can imagine for a pothole event may be a rather important item to have some control over as an engineer trying to improve vehicle performance over the pothole. So they can go through and look at the shapes of those curves and edit the shapes of those curves if they want to. And the property files also have to get their own tab there too. And finally, the design objectives. We'll be looking at pitch angle and pitch rate, for example, going over that pothole, maybe trying to come up with sort of an optimal range there. So they've gone off and launched the analysis now from the analysis tab, same as we showed before. They've streamed status here and here, so you can see it was simulating, job completed, and now they've clicked on a hyperlink to get a version of their workbook now extended with the output. So they could look at those pitch angles, design objectives. They can now look at the plots. There's a little index page there. They can go and look through the plots and see the forces and the springs and dampers, look at the pitch angle, and maybe say, I don't know, it's pitching quite a bit. I'd like to see if I could make the vehicle pitch a little less, bounce up and down a little less when it goes over that pothole. So what if I just stiffened my dampers by 1.5? So that's just going to scale the same force versus velocity curve. It's not going to change the shape of the curve. It's just going to scale that curve. And okay, I want to try that. So they go off and do the same thing here. Submit the job from the Atoms Explorer server tab in Excel. Hit the stream status button and see, okay, simulating, done, great. And then go click on this hyperlink, grab the workbook with the answers in it. And then they can come in here and look and compare the another table here of those output objectives. See, my max pitch angle is now down a couple of degrees. Happy about that. 5 or so degrees versus 7 or so degrees. And I can look at my plots of, again, plots of pitch angle and the forces and springs and dampers. Similar to what we saw in Adam's View, the Adam's View slides there. This engineer now could email this spreadsheet workbook back to CAE analyst, who could then import that into the model, their model, and update their model with these favored settings from the engineering community at their company. Okay, just a couple slides to wrap things up here before we open it up for questions and answers. There are a few frequently asked questions. What do I need to have to do this? So you'd need to have Adams 2016 or later. You would need Adams Excel, Microsoft Excel, or as I mentioned, any supported XLSX viewer. And you need the ability to include the MSC Adams Explorer add-in for Excel into Excel. So again, that, depending on IT policies and such at your company, that may be something you need to have the IT folks look at and do for you, depending on what you're allowed to do, not allowed to do within your organization. And then, of course, you need to have a configuration whereby the consumer of the Excel workbook can reach out to the external computer that's got across the network and touch that machine on that network that runs Adams. Or, again, in some cases, could just be sort of all on the same machine. Again, we talked about the benefits of this for just an Adams user themselves. So some Adams users may just want to do this themselves on their local machines. Just a few words briefly on resources. There are, where to get help in general, and including things related to Adams Explorer. In addition to emailing your favorite Adams tech support or technical field representatives, talking to them about this, we can go on to the MSC communities and get into the forum there. Also, there are some examples of Adams Explorer built into, we get new feature examples with every release. So with the 2016 release, there's a set of tutorials for this. And then moving forward, we took those tutorials and put them into the documentation. So the product documentation for every release now moving forward till perhaps the end of time will contain a couple of example tutorials on how to use Adams Explorer in Adams View and an Adams car. They may look very similar to the ones you just saw here today. So.